Good day, students. Welcome to math.serve.com. And this clip we're going to be going over section 1.1c of our virtual calculus text. We're going to be looking at how to evaluate limits graphically. For more tools and support resources to help you pass your AP Calculus AB exam, do visit our website at math.served.com. Before we get started with the examples, we're going to take a look at 4 cases that you need to keep in mind when looking for limits graphically. Okay, so the cases are as follows. So this is for finding limits graphically. Alright, so the first case that you will come across is the situation where you will be approaching a point. Alright, something that you want to keep in mind is that the point has to be a non-isolated point. So you have a point that is not isolated. Alright, so keep that in mind. The point has to be connected to the graph in the direction that you're approaching from. So if you're approaching a point that is not isolated, the limit is simply going to be the y coordinate of the point that you're approaching. Okay, this point can be open or closed. All right, you can keep that in mind. This point can be an open circle or a closed circle. So let's put that there. But the bottom line is that the point is not isolated. Alright, so when approaching a point, the y-coordinate is your limit. Secondly, you can be approaching a vertical asymptote. Okay, when you're approaching a vertical asymptote, the limit is pretty straightforward. If you're heading upwards, your limit is going to be infinity. If you're heading downwards, then your limit is going to be negative infinity. Alright, another case to keep in mind is a scenario where you approaching a flat line, basically a horizontal asymptote. Horizontal asymptote. In this case, the limit is going to be, let's call it a k value, where y equals k is the equation of the horizontal asymptote. Okay, let's just call it HA. So if you're approaching a flat line or a horizontal line, a horizontal asymptote, the y value that you're approaching, which is basically the equation of the horizontal asymptote, will be your limit in that case. Okay, and then lastly, you could be increasing or decreasing. Alright, so in this case, it's just like the vertical asymptote. If you're increasing, your limit is going to be infinity, and if you're decreasing, your limit is going to be negative infinity. Now for 1 and 2, these two are the cases that apply to finite limits. Okay, so these two are finite limits. And then case 3 and 4 apply to infinite limits. Alright, infinite limits. So we're going to be looking at these 4 cases in the examples contained in this presentation. Alright, so for these examples, we're going to evaluate the limit, the given limits graphically. Okay. Alright, so for number 1, we have the function f of x here, the blue function. So in this one, we're looking for the limit as x approaches The limit as x approaches 1 from the left of f of x. Okay? Okay, so let's go ahead and use a graph to solve this problem. So we are approaching 1 from the left. This is known as a one-sided limit. So this is 1 right here. So what we're doing is we're approaching 1 from the left direction. Okay? So when you're approaching 1 from the left, you put a 1 in the direction as a power, assigned power of the number. Okay? So if you come in to 1 from the left, you look at the function that's to the left of 1, and that's this blue function right here. And you notice that this horizontal line, I meant to say, is approaching a point, this point right here. Okay? So in this particular example, we are approaching a point. That's case 1. And do you remember what's the limit is? When you're approaching a point, so the point that we're approaching is 1, 0. So when you're approaching a point, in this case we are approaching it from the left direction, the limit is simply the y-coordinate. Okay, so the y-coordinate of this point, 1, 0, is going to be the limit. So the answer, limit as x approaches 1 from the left of the function, is equal to 0. Okay, so what this basically means is, in this graph, when you get infinitely close to 1 from the left direction, the function is approaching the value of 0. Okay? Alright, let's take a look at question 2. What if we want to find the limit as x approaches 2 from the right of the function? Alright, so let's go ahead and take a look at that. So we're approaching 2 from the right. So this is 2 right here. So we're approaching it from the right. How do we know it's from the right? Well, the sign power is positive, so that's 2 from the right. Alright, so you're going to look at the function that's active to the right of 2, which is this function right here. So when you're getting infinitely close to 2 from the right, like this, okay, this is right, the question is, what are we approaching? In this case, we're approaching an open circle, okay? The point that we're approaching could be open or closed, it doesn't really matter. But the bottom line is that we are approaching a point, okay? A point that's not defined. So since we're approaching a point, all we care about is the coordinates of that point. We're approaching the point 2, 5. Okay, so we're approaching the point 2, 5 from the right, and the limit is going to be the y-coordinate of that undefined point that we are approaching. Okay, so the limit as x approaches 2 from the right of the function is 5. Okay, so as x gets infinitely close to 2 from the right, the function approaches 5. Remember, the function doesn't have to get to 5. We're looking at what the function approaches. Alright, so a limit does not have to be approaching a defined point. It could be approaching a point that's undefined, as is in this case, but what we care about is the y-coordinate of the point that it is approaching, whether it's defined or not. Alright, let's go ahead and take a look at question 3. So for question 3, let's say we're to find the limit as x approaches -2 from the right of this function right here. Okay. Alright, so let's see, we are approaching -2 from the right. Let's look at where's -2. That's -2 right here. So if we're approaching from the right, we have this positive sign power, which means we're approaching from the right direction, this value right here. So we're approaching -2 from the right. Okay, so when you're approaching -2 from the right, you look at the function that's to the right of 2, which is this function right there. So the question, let me put a barrier line to help you see what's going on. So this is the value, the x value we are approaching right there. Okay. All right. So now the question is, what are we approaching as the graph gets infinitely close to -2 from the right? So you're approaching what? What are we approaching? We're approaching a point. Okay. So in this particular case, let's write it down. We are approaching the point. What are the coordinates of that point? We're approaching the point -1, comma, I'm sorry, we're approaching the point -2, comma, -1. Okay? From the right. Now, what's the limit when you're approaching a point? When you're approaching a point, whether defined or not, the limit is your y coordinate. Okay, so that simply tells us that the limit as x approaches -2 from the right of the function is the y coordinate of the point that it's approaching, which is -1. Okay, so that's that. All right, let's take a look at question 4. In question 4, what's the limit as x approaches 0 of the function? Alright, before we do this, let's go back to our opening notes. There's a point that I would like to make real quick. So there's a point I would like you to note concerning double-sided limits. Okay? Note concerning double-sided limits. And one thing that you want to note concerning double-sided limits is that if the left-hand limit is not equal to the right-hand limit, then that basically implies that the double-sided limit, limit does not exist. Okay, does not exist. All right, so we can put this into shorthand. If the LHL, left-hand limit, is not equal to the right-hand limit, and that implies that the DSL, the double-sided limit, does not exist. Okay, so let's keep that in mind. All right, so number 4 is a DSL. It's a double-sided limit. How do we know that it's a double-sided limit? Well, there's no direction provided, so we're going to be approaching 0 from the left and right. Okay? Alright, so let's go ahead and do that. We're going to start by looking at the left-handed limit. Alright, so the left-handed limit is a limit as x approaches 0 from the left of the function. Okay, so if you're approaching 0 from the left, this is approaching 0 from the left, what's happening with the function? You're going up towards what? You're going up towards a point, this point right here. Okay, what are the coordinates of that point? The coordinates of that point is 0, 4. Alright, so since you're approaching a point, guess what? Your limit is going to be the y coordinate of that point, and the y coordinate of that point is 4. Okay? So you need to do your left-hand limit, and you also have to do your right-hand limit and compare them. Okay? So from the right, we're looking at the limit as x approaches 0 from the right of the function. So when you're approaching 0 from the right, okay, what's going on here? Well, you're ascending towards, guess what? The same point, 0, 4. Okay, so the y-coordinate of that point is going to be your limit. So your limit here from the right is equal to 4. Okay, so let's take a close look at this. Your left-hand limit and your right-hand limit are equal. What does that mean? This follows that the double-sided limit is going to be exactly equal to that. Alright, so this follows that the double-sided limit, which is the limit as x approaches 0. Now, if there is no exponential sign direction to the number that x is approaching, then that means it's double-sided. Okay, so this basically has an invisible plus or minus here, but customarily we don't put it. Alright, it's just implied that if there is no direction, it's a double-sided limit. Okay, so the double-sided limit is equal to 4. So what it is basically means that if you're getting arbitrarily infinitely close to 0 from both sides, the function is approaching the value of 4. Alright, now let's take a look at question number 5. Now for question 5, let's say you want to use the graph to find the limit as x approaches -3 of the function. Alright, so what you notice here is that there's no direction. So what does that mean? If there's no direction, that means it's a DSL, it's a double-sided limit. So we need to do the left and the right. Okay, so let's start with the left-hand side. So the left-hand limit is the limit as x approaches -3 from the left of the function. Okay, so this is -3 right here. So what are we approaching? Now you know that we have an isolated point here and we have an open point here. We indicated earlier in the notes that you never approach an isolated point. So this is a distractor right here. We're going to be approaching this point that's connected to the graph in the direction that you're coming from. So what direction are you coming from? You're coming from the left direction. Okay, that's -3 from the left. That's the left. What are you approaching? You're approaching a point that's undefined. Okay, so the point that you're approaching could be defined or not. It doesn't really matter. So in this particular case, the y-coordinate of that undefined point is going to be our limit, and the y-coordinate is 1/2, 0.5. So that's the left-hand limit. The right-hand limit, the limit as x approaches -3 from the right. Well, in that direction, we're approaching -3 from the right. So on the graph, guess what? We're approaching the same point, which is an undefined point right here. So the right-handed limit, the limit of the function as x approaches -3 from the right, is also 1/2. Okay, so what about the double-sided limit? It's going to be equal to both of them since they're equal. Alright, so the limit as x approaches -3 from both sides, so you don't put any number, of the function is equal to 1/2, since the left and the right hand limits both have this value. Alright, so that's that. Okay, so question 6. Let's take a look at this. So for question 6, what if we were to find the limit as x approaches -3 from the right? Okay. Alright, so let's look at that. So we're approaching negative 3 from the right. So this is negative 3 right here. We're approaching, change the color. This is negative 3. We're approaching negative 3 from the right. Okay, so negative 3 with a sign power of positive. That indicates that you're approaching it from the right. So when you're approaching negative 3 from the right, what we're looking at is this portion of this rational function right here. Okay, because it's to the right of negative 3. So what is it doing? This function is approaching a vertical asymptote. Okay, so we talked about this earlier. If you're approaching the vertical asymptote, if you're going up, then your limit is going to be infinity. If you're going down, it's going to be negative infinity. So what is the case here? The function from the right is tending upwards towards infinity. So what does that tell us? It tells us that the right-handed limit, the limit as x approaches negative 3 from the right of the function, is simply infinity, since you're going upwards in the direction of the vertical asymptote. Had it asked for the left-handed limit, in that case your answer will be negative infinity, since it's going downwards from the left of negative 3. Alright, let's take a look at question 7. So for question 7, let's say you're to find the limit as x approaches negative 1 of the function. Alright, so in this particular case, there's no direction provided, so it's a double-sided limit. What does that mean? We have to find the limit from the left and the right and compare them. If they're the same, then that's going to be our double-sided limit. If they are different, then the limit does not exist. Okay, so let's start from the left. So from the left, we're looking at the limit as x approaches negative 1 from the left of the function. So yeah, if you're approaching negative 1 from the left, so that's negative 1 from the left. The question is, what are we approaching? In this particular case, we're approaching the vertical asymptote. Okay, we're approaching it from the left direction. In that case, we're going where? We're heading upwards towards infinity. So the left-handed limit here is simply going to be infinity, because to the left of this negative 1, the function is tending upwards towards this vertical asymptote. Now how about the right? Let's take a look at that. So for the right, we're looking at the limit as x approaches negative 1 from the right of the function. Okay, so now we're approaching from the right. Okay, negative 1 from the right means you have a power of positive. So in this case, we are approaching the same vertical asymptote from the right, but in this case, we're going downwards towards negative infinity. Okay, remember when you're approaching the vertical asymptote, if you're going down is negative infinity, if you're going up is infinity. In this case, we're going down, so it's going to be negative infinity. Okay, now check this out. Our left and right hand limits are different. So what is the double-sided limit going to be? Since the left and right hand limits are different, our double-sided limit will not exist. Okay, so the limit as x approaches negative 1 of the function does not exist, because the right and left hand limits are different. Alright, let's take a look at question number 8. So for question 8, we are looking at the limit as x approaches negative infinity of the function. Alright, so this is an infinite limit example. Now in this case, we're going to look at if we are approaching a horizontal asymptote, a flat line, or if the function is increasing or decreasing. Okay? So think about end behavior. This is exactly the same thing as end behavior. Alright? So in this case, this is negative infinity right here. If the function is heading towards negative infinity to the left, what kind of behavior is the graph displaying? The graph is heading downwards. Downwards towards what? Negative infinity. To the left side, the graph is doing what? The graph is decreasing. So what's the left-hand limit? Was it limit towards negative infinity here? Since the function is decreasing in the direction of negative infinity, that means that the limit is going to be negative infinity. Okay? So the limit as x approaches negative infinity of the function, we're looking at the end behavior. Since it's pointing downwards, that means towards the end, is going to be decreasing towards what? Towards negative infinity, because it's decreasing forever. All right? So that's that for question number 8. All right, let's take a look at question number 9. So what if you're to find the limit as x approaches negative infinity of this function? Alright, so this is another infinite limit, okay? So we're looking for, is it a horizontal asymptote or is it increasing or decreasing? At negative infinity, what do you notice the behavior of the graph is? Is approaching a flat line. It's approaching a horizontal asymptote. There goes your horizontal asymptote right there, okay? So the equation of your horizontal asymptote is basically going to be what your limit is as x approaches negative infinity, okay? So your horizontal asymptote has the equation y equals negative 3. So guess what? The limit as x approaches negative infinity, it's flatlining to the horizontal asymptote. The horizontal asymptote with the equation y equals negative 3, so the limit is going to be negative 3 for x equals negative infinity. All right? Now, what if you were asked to find the limit as x approaches infinity? If you're asked to find the limit as x approaches infinity, that is known as the right end behavior. Okay? So guess what will happen? You're approaching the same horizontal asymptote, so the right end behavior will be negative 3 and the left end behavior will be negative 3 also. Alright, so how well did you understand the contents of this presentation? Well, we have some practice problems for you to try out. We'd like you to try out these problems. So try these. Okay, so what you're going to do is write down your answers. Pause the video after you see the questions, write down your answers, and then click on play, and then you see what the correct answers are. Okay, so for question 1, what is the limit as x approaches negative infinity of the function? For question 2, what is the limit as x approaches negative infinity of the function? For question 3, what is the limit as x approaches negative 1 of the function? Number 4, what's the limit as x approaches negative 3 from the left of the function? Number 5. What is the limit as x approaches 1 of the function? Number 6. This is a double-sided limit. What is the limit as x approaches 1 of the function? Number 7. Number 7, what's the limit as x approaches 0 of the function? And then number 8, what is the limit as x approaches -2 of the function? Okay, so at this point, go ahead and pause this video and try out these problems. We'll be displaying the answers momentarily. Alright, hopefully you have had a chance to try out these examples. The answers are as follows. So for question 1, the answer is 4. For question 2, it's going down to -infinity. Question 3, it's 2. And then question 4, -3 from the right, it's going to be -2. Question 5, you're approaching 1 from both sides, but from both sides you're approaching the same point, which is 1, 4, so it's going to be 4. Number 6, for number 6, you're approaching 1 from both sides, which are different, so the limit does not exist. Alright, and then number 7, you're approaching this point right here. Remember, you never approach an isolated point. Okay, you're looking at this open circle right here. You're approaching the open circle from both sides. So you're going to be looking at the y-coordinate, right, of that point that you're approaching. The y-coordinate is 3. And then for question number 8, you're approaching -2 from both sides. So you're approaching this open circle right here. You're approaching a point. The y-coordinate of that point is +1. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of limits, to give us a thumbs up. We appreciate your positive feedback. If you have any questions or comments, to post it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for the remainder of this virtual text review series. More videos, worksheets, games, and support resources can be found at mathcodeserved.com. Thanks again for watching, and have a wonderful day. Goodbye.